welcome back everybody in Hall 6. It's 11 a.m. Doubling down on the topic of security. We heard before all the eBPF related topics. We now have a subject matter expert on this topic, Kubernetes Security's challenges but also opportunities. He's from Vienna, he's a pen tester, a renowned security consultant. He's the managing director of Certitude Consulting, Marc Nimmerrichter.
Thank you very much. Thanks for having me. I will talk about Kubernetes security aspects today. So who am I? I've been in IT security for the last more than 10 years, mainly doing pen testing, application security, dealing with like security architectures, things like that. And I'm working for Certitude. We're a consulting firm for IT security. Also dealing with a lot with Kubernetes or OpenShift security aspects, pen testing and these sort of things, but also with the more like GRC and compliance aspects. We also have a team for that. Yeah, the agenda, I will start with what is a container, what is Kubernetes. No, just kidding, I will skip that. I will give you an overview of the Kubernetes attack vectors. We will talk a bit more about security architecture in general and also about the security opportunities Kubernetes provides. So in previous talks, I have talked a lot about vulnerabilities and how to hack systems and vulnerabilities we find frequently in pen tests. And I always created the impression as if it was all bad in regards to Kubernetes security, and I thought, okay, that's a bit unfair. So I want to do it differently this time, so I want to really spend more time. We'll also talk about attack vectors and security issues, but I want to spend more time also on the opportunities and the mechanisms Kubernetes provides to build and design secure systems. So let's dive right into it. I tried to picture a kind of Kubernetes attack chain example. So of course, it's a complex system. There are many attack vectors from different angles. But let's say for an outside attacker who doesn't know anything or doesn't have any credentials and any access to the cluster so far, the attack chain is involves quite a lot of steps. So an attacker could, for example, find an application vulnerability, get code execution in the application, for example, with a command injection vulnerability or also with a, deserialization vulnerability or something similar. If the image is not well hardened, then it's very likely that the attacker will find a shell in there. With this shell, the attacker owns the container and has arbitrary command execution in there. Then there is another big step the attacker has to take, and this is kind of somehow escape the container. I mean, if the application is the goal, then the goal is probably reached there already. So the attacker is in the container. The attacker has probably access at the same level as the container has, for example, to the database. It could be game over here already, but if the attacker wants to go for the whole cluster, then there is a big step the attacker has to take, and this is a container escape, which is not easy. Sometimes it's possible with configuration issues that the DevOps guys made accidentally. But sometimes, the attacker might also have some weapons available that's like 0 days or something similar that lead to kernel exploits that allow the attacker to escape from the container. And once you're on the node, you can compromise other workloads, and from there it's not far to really owning the whole cluster. So this is one example of an attack chain. Of course, if the attacker has some level of access already because he compromised a dev PC, for example, and got access to a kubeconfig file, the attacker can skip most of the steps and already start with breaking out of a namespace or something like that. So as defenders, we have a hard job. We have to secure the application code, which is hard enough already. We have to secure the configuration of the application. That's probably within the image or within the application itself. We have to deal with image vulnerabilities, harden our images, make sure the software is up to date. We have to deal with pod runtime configuration. So for example, the privileges of the container, the user the container process runs under, or namespaces that might be disabled and lead to security issues. All these sort of things. Cluster configuration, so not all defaults or not all Kubernetes defaults are secure. For example, seccomp profiles are not enabled by default, so these are some things that we have to take care of to enable these defaults to achieve a higher level of security. We need to keep our cluster software up to date. This is also something more difficult as it sounds, because there are many components. We have all our images and code, but we also have the Kubernetes, we have the CNI plugin, we have some other operators that run on our in our clusters. We have, of course, the nodes and the node operating systems, kernels. So yeah, quite a bunch of software that we have to take care of updating, and of course we have interdependencies between the versions, so yeah, hard enough. And we have to take care of isolation between namespaces and tenants, at least if we deal with multi-tenant clusters. And then there is the access by devs, by ops, by administrators. Yeah, we have to keep kind of secure our credentials, make sure that we have some sort of need-to-know principle, that everyone has access only to these objects and Kubernetes resources one needs access to. So yeah, it's quite unfair. The attacker just needs to find a few loopholes. We have to take care of securing the whole cluster and all its components, but this is what security is all about in all cases anyway. There's another nice kind of threat matrix. You might have seen it. It's released by Microsoft. They also try to kind of list the Kubernetes attack chain and the different kind of attacks you can have at different stages of your attack, like for initial access, for code execution, for privilege escalation, until impact on the far right. So it's quite a nice overview of the different things you have to secure, have to take care of, or for an attacker, of course, or for a pen tester, it's a nice kind of checklist of what could go wrong. It's not entirely complete, so I'm missing container runtime vulnerabilities here or kernel runtime vulnerabilities here that we have had in the past already to kind of break out of containers, but still it's a good start. And yeah, of course, also here we could somehow draw, as an attacker, draw some sort of attack chain. So could also start here with an application vulnerability. We could get a bash in the container, try to create a privileged backdoor container that is probably, hopefully stealth, so that it doesn't really that isn't detected by the security guys. So we could just give it a name that's very similar to the names that exist in the cluster already. Yeah, we could read out Kubernetes secrets. We could do some ARP spoofing and IP spoofing. So we have one overlay network. So this is something people should be aware of in most cases. And yeah, until we finally do the impact. Of course, we don't need to go through all these steps. So an attacker, once he has a privileged container somewhere, could go right to impact right away. So yeah. So it sounds very tricky, so it all sounds as if like Kubernetes environments make a lot of open a lot of attack vectors. But I think also the level of security we want to have in the Kubernetes cluster is also higher than compared to monolithic architecture. So if you look at like our legacy systems, there we had probably one maybe war file where all our application components were deployed in, like a UI service, account service, inventory service, and so on. So in this example, we had all these things in our application server as one war in one process on one system without any isolation between them at all. Then we had the database. So this is like the traditional way. Yeah, now we have all these little services, and we want to have certain levels of isolations between them, and this is not something that anyone would have required for the traditional systems. So actually our kind of security level or security requirements have risen. So we really want to isolate the different components. And this is really, I think, something that's an advantage in terms of security that we get with Kubernetes. We have all these smaller environments, these smaller services that have some level of isolation between them. So if, like here, the account service was compromised because there was an issue in the API that led to code execution, then the attacker would have code execution on the whole web application server. So with all its components, here the attacker would just have access to the inventory service and would be confined to this kind of isolated environment as long as he doesn't break out of the container. But at least there is a certain level of isolation. So if we compare it, on the left side we have maybe strong isolation. We have different physical hosts. We had different VMs that gave us a strong isolation, but not very granular. And on the right side, we have very granular isolation, maybe not as strong as hypervisor-based isolation, but still we have more of it. Yeah, this is exactly what this slide shows. Yeah, actually there is namespaces for Kubernetes, kernel namespaces to isolate the containers, and there are Kubernetes namespaces to kind of isolate the Kubernetes objects, but at least group them. Yeah, so we can, in terms of security, we can then kind of try to have different projects and different teams on different namespaces and have some level of administrative kind of separation between them. So Yeah. So let's talk about the advantages of this kind of architecture that we get with Kubernetes usually. So we have smaller components that are more comprehensible. This gives us the chance to harden them. Sounds very easy, but like trust me, on the traditional systems, nobody really kind of was brave enough to touch the system and to strip away certain operating system components because people were sure something would break or something in future would break and nobody would know why. So this is why hardening was like not really done or not really done a lot on like traditional systems. But now we have very small units, people, development teams understand very precisely what this system is doing, what the requirements are. They can test it well, so they know, okay, if they harden their image, then they can test it. If it works, it will work. Yeah? It doesn't have an impact on anyone else. Yeah? The other teams have other images. They do their own testing, do their own hardening, and they really know what they can do and what they can't. So yeah, this really gives us room for hardening. It also gives us room for security policies. We can really pin down what a container process is allowed to do. And typically, a container process only needs to execute, for example, one process, which is, I don't know, maybe the Java application it runs inside, or the Python application, or whatever. We don't want any other processes in this container. And actually, we could define policies, for example, with Falco, or other open source or commercial tools that really only allow a specific binary to be executed in this container. If something else is executed, it would be an anomaly. So we could have very precise and very granular anomaly detection on the process level, but also on the network level. So we can define what sockets we expect to be open. We can define what outgoing connections we expect, and also on the network level. So these are very, very good means to kind of increase our isolation and our security posture if something happens, and to have some detection. Yeah, also infrastructure as code. So talking about legacy application, who in the room can say that they and their team and their organization is good at documenting things? So okay, I see 2 hands. Not really sure if I trust you. Please come on stage and explain how you do that. So generally, yeah, everyone tries, but yeah, it's very difficult. I mean, I trust you. Probably there are some companies who do this right, but it's very difficult to keep the documentation updated and really usable by everyone, understandable by everyone. So this is something infrastructure as code gives us. So we get that with Kubernetes. So we have a common language between the devs and ops, and even not even the humans, devs and ops, but also the orchestrator. So we have a common language between dev, ops, and even the orchestrator. And as we know, it's a declarative language. We define what we want to have, what we want to expect, and the orchestrator makes sure it will work. And with this, we get an up-to-date documentation that's a single source of truth. And I think that's, for security, this is really a big step forward. Because yeah, people can understand the system, and if people can understand it, they can secure it. And if even machines can read this documentation, then yeah, we even can automate this kind of security. We have smaller lateral movement scopes. So lateral movement is, yeah, for an attacker, the way to kind of jump from one component to another. And as I said, yeah, if I kind of compromise a system and I own all the components, that's bad. Yeah, here I own a service. It's only a single part of the application, and I can't really easily break out of that. We have OS and infrastructure. We are OS and infrastructure agnostic, so the devs don't need to understand like all the infrastructures, you know. So this makes a lot of things easier. We have this standardization that makes this or avoids this handover between devs and ops. So and also in terms of security, that's a big advantage. We have the immutability. So when something goes wrong, we just, I don't know, restart the container, restart the node, and we have a clean state. Yeah, even if the node gets compromised, kind of we can recover from that. Much easier than with like traditional systems where persistence was much more of a problem. Yeah? I mean, persistence, for an attacker, persistence can be achieved with other means, like changing the Kubernetes configuration, adding some I don't know, resources like containers and things like that. But still, like on a system level, it's more difficult. Privileged access was a problem. So whenever an administrator, also someone from development, needed access to a machine to debug something or to fix something, he usually got administrative access to the whole operating system, and yeah, at least for a specific amount of time. With Kubernetes, we usually, yeah, we can, and hopefully we do, restrict these privileges to just the namespaces or the objects that this particular administrator or dev or ops guys guy needs this access for. So we get more granular privileged access management. We have network segmentation even between components. So the inter-process communication between our containers, it's clearly defined, and is also in terms of security is clearly needs to be allowed explicitly. Otherwise, containers will be isolated. On the network level, it's different. So on the network, we have one overlay network, communications by default allowed, but we can restrict it with network policies or other means like service mesh. We have a well-defined ingress, so someone can't accidentally kind of expose a service easily. So this is also an advantage. When we talk about some other architectural stuff, so usually people always compare VMs with containers, and then they say, okay, with VMs we have a hypervisor which is more secure, with containers we don't. So yes, this is true, but nobody says that all your containers need to run on the same virtual machine. So you could have like host groups or something like that to have achieved the same level of isolation. But true, of course, if you compare one container with a VM, then of course you have the shared kernel, and the shared kernel leaves some room for kind of container escapes, and once there's a container escape, then that's bad. But this could compromise the whole cluster if we don't have a kind of architecture that prevents that. So, but how to prevent that? With traditional like CRI-O or Docker, our containers, as you know, are just processes with certain kernel features enabled, like the kernel namespaces and the C groups and seccomp profiles and like SE-Linux and these sort of things. So it's basically just a process with some kernel security features on top of that. It somehow works for isolation, but it wasn't really built for that. So we have a large attack surface in the kernel. The kernel is like millions of lines of code, and like every now and then a new zero-day or a new vulnerability gets released, and then of course everyone is kind of rushing to patch their kernels, especially on their Kubernetes environment. So this is definitely a risk, and there have been container escapes in the past where someone, by just executing something in a container, executing a few lines of exploit code, could break out of the container and even be root on that container, like escalate from a non-privileged container that runs under, user ID 1000 to root, so user ID 0 on the node. So this exists, so it's definitely a risk. You should consider. If like this level of security is important for you, like in multi-tenancy environments and things like that, then even Kubernetes or the Kubernetes ecosystem has some answers for you, or some things that you might consider, like container sandboxes that are built for security. You might have heard of Nabla container or Kata containers. So Nabla containers, their approach is to have a library operating system that runs in the process. So the most part of the operating system, which usually is executed by the kernel, so your system calls, is implemented in the container itself, so in user space. And that means that the attack vector is really reduced to, I think Nabla container only uses 7 system calls out of more than 300 that exist in Linux. So this really reduces the attack surface by a lot. And it means if an attacker exploits kind of a vulnerability in a system call, then it will be confined in user space. So the process will be affected, but not the host itself. And another approach in Kata containers, for example, is to have a hypervisor-based containerization. So it's like a mix of containers in terms of you can use it like a container, it behaves like a container, it complies with the OCI runtime spec and the OCI image spec, so it really behaves like a container, and you can plug it into Kubernetes like any other runtime. But what it does is it starts a microkernel that then isolates that implements the kernel for this one single container. So every container gets its own microkernel. So then you have the same level of isolation as you had with VMs and hypervisor-based isolation. So definitely something you want to look at if security is important for like certain parts of your application, or if you for your whole platform, if you're thinking about sharing the cluster or things like that. And even the hyperscalers, like they use approaches like this. So Kata containers, like Amazon Firecracker, is something similar to Kata containers. So in like AWS Lambda or other like serverless AWS offerings, then they use Firecracker, where yeah, if you run a container in there, then it will have its own VM, or at least no other customers will share the same kernel with you. And yeah, Google has a gvisor, which is something similar to Nubler containers you see on the left. So they implement most parts of the system call in user space. So within the user mode process, and kind of if you do system calls, it will be kind of inspected in terms of which parameters, and if it's dangerous, it's filtered. So these are approaches that, yeah, also the hyperscalers use when they want to use something like shared clusters, or when they want to do multi-tenancy, hard multi-tenancy. Yeah. Speaking of multi-tenancy, generally I highlighted here the pros and all the advantages that Kubernetes will give us in terms of security, but I want to add this disclaimer. So for hard multi-tenancy, so if you really want to share your cluster not between teams in your organization, that would be soft multi-tenancy. But if you want to achieve hard multi-tenancy, so sharing the cluster with different customers that might be hostile to each other, then I would definitely recommend take a step back and really think about what you're doing. I mean, you can do it, but it's not easy. It doesn't come for free. It doesn't come by default. There are a lot of things that you need to take care of, and you need to have the team and the know-how behind it to really operate such multi-tenant clusters. So what you need to take care of is, for example, node pools. So you shouldn't share nodes. So even the big hyperscalers, they don't. So they use either separate node pools, or they use secure container runtimes, where you have really your own hypervisor per container. You would need to think of overlay networking. So by default, most of the time you have like one big overlay network. So you need to kind of split that into multiple overlay network, at least per customer, or do something with network policies to achieve something similar. You need to think about admission controllers, because you don't want to have privileged containers on your clusters. You need to have like pod security standards or other like security enforcement in terms of admission controllers or something similar in place to avoid certain dangerous workloads. You need to have like separate namespaces. You need to have role-based access control to restrict access on the Kubernetes API level. You need to think about quotas. You need to think about performance risks, storage isolation. You need to have an up-to-date cluster all the time. So if the next 0 day comes, you need to be able to patch that very, very quickly. And all exposed components must support multi-tenancy. So we have seen in pen tests like something like multi-tenant clusters, and most parts were isolated very well, but then they had some like monitoring systems on top of that, so that customers could monitor the like operation, like if all their pods are running and things like that. And here it wasn't isolated well between the tenants. So with this monitoring system, which should just kind of read information from the cluster, we were able to compromise other customers on the same cluster. So you really need to think of all the components and software you put on top of your cluster, and ask yourself if multi-tenancy is working with them, and if it's isolated well. Yeah, then there are all these little configuration issues, of course. You need to make sure that if you share the nodes, that one tenant cannot use another tenant's private images. By default, images are cached, so yeah, they are on the node, and yeah, you don't want one tenant to access other private images. So, and there are many little things like that, so I can't list all of them, but yeah, I just want to highlight there is no room for mistakes. If you're really thinking about hard multi-tenancy, then I would recommend think carefully about it. For soft multi-tenancy, yeah, if you like have a secure architecture, and if you engineer your cluster well, then I think this is easier to achieve in a secure way. Okay, yeah, there are many free tools available, like static scanners that scan your infrastructure as code, so your Docker files, your Kubernetes configuration and things like that. There are dynamic scanners that even kind of probe your live systems. There are, of course, image scanners. There are tools scanning your role-based access control to make sure it's right. Yeah, so role-based access control can be tricky, has some limitations, and yeah, so these tools can give you a nice overview. Anomaly detection. Yeah, this is also something you might want to consider. As I said, we have all these small services that are well defined. We know what they are doing, so we could easily put a policy on them and kind of restrict them to this particular purpose. So if something else happens, then we know it might be an attack. So This is quite neat. And yeah, policy enforcement. So like Open Policy Agent Gatekeeper, that really allows us to define what workloads are allowed to run on my cluster and things like that. So to wrap it up. So I'm often asked, so is Kubernetes more secure, is it less secure? Like security teams kind of complain that their dev teams, they are running forward, going forward with Kubernetes, and they don't really know how to deal with that from a security perspective. So I think if you have like a larger, if you're a development company, you develop lots of code, and you reach a certain break-even point, then you will kind of, and you are able to reduce the overall complexity of your systems with Kubernetes and increase security. If you're just implementing Kubernetes for a small application, then it's probably too much. Then yeah, Kubernetes adds a certain level of complexity, and you need to kind of scale that to have the benefits from it. So this is on a high level. This is my overall like recommendation for whom it might fit and for whom it might be too much. Of course, you need to have the know-how in the team and in the company. This is usually also an issue. If you have the know-how in the team, also in the security team, then it's probably easy to deal with that. If you don't have it yet, then you need to build it. So this is really important. Yeah, as we know, the tech vectors are a lot, and yeah, need to deal with them in some way. Yeah, and this is it. This is my last slide. So Kubernetes adds a complexity layer. Kubernetes adds new vulnerability types that you have to take care of. It's not always secure by default. As I said, seccomp, for example, you might want to enable it once you have installed your cluster. I would recommend think twice about hard multi-tenancy. It's possible, but it's difficult. But if you do your homework, if you do your like security reviews, if you really consider security early in the life cycle and throughout the whole life cycle, if you have good concepts, then I think you might even really reach a higher level of security as you had in your traditional legacy systems, let's say. And this is it. Thank you.
All right, great. Thanks for the awesome talk. We still have some minutes left, so if you have any questions, feel free to bug Marc as you like. Yeah, I see a hand over there.
Thank you, first of all. I will admit, maybe I will be lynched, but I've worked a lot in traditional system administrative things. And one thing, I mean, I think you're right for the most part. It's just that lately, even in traditional systems, we've been moving to containers with LXC and making things as small as possible. And moving more in the Kubernetes style. But one thing that I noticed is that usually Kubernetes, you have to run it in privileged containers. And what I would like to do is have multiple multi-tenant Kubernetes class, as in single tenant, but many Kubernetes clusters to solve the multi-tenancy problem. But I don't want to run virtual machines and then have my Kubernetes running on a virtual machine.
Yeah.
And I am asking this question a lot, but like the best way to find some way to run Kubernetes on a container, what options you think would be best to run it on a container without having to run it as a privileged container? Because I noticed there's also Kata you mentioned, but that's for running containers with the hypervisor on a Kubernetes cluster. But in terms of running a Kubernetes cluster on something like this, what options are, what would be the great way to do that?
So I'm not sure if I got the question right, but if you mean that you have like, do you want to avoid nested virtualization?
Well, if I had enough money to buy one node per Kubernetes node as hardware-wise, I could do that. That would be my preferred, but I don't have like the funding to buy one node per Kubernetes. So, but I would like to use it unprivileged and make sure that it's secure, but I don't want to use virtual machines because they're too much overhead and too...
Yeah, but what do you mean by unprivileged? I mean, you have some privileged containers, for example, that are needed by your control plane, but then most of your workloads should be unprivileged.
Well, I meant also the control plane. Everything should be not privileged on the host hardware itself. That's what I would like to avoid. The entire cluster. Then I have to use virtual machines, or?
Yeah, not sure if Not sure if I get the question right, but also not sure. So I'm not sure how you'd solve that. I mean, if you're thinking about having a cluster per purpose, so having many clusters to solve the multi-tenancy issue, I mean, there are projects like, I don't know if you have heard of Gardener, for example, or other that are kind of orchestrators for like multi-cluster orchestrators that you could use, and they are meant to not organize or orchestrate single containers, but orchestrate whole clusters. So you could give every team a cluster with just a click that's well isolated from other clusters, and you could even deploy it like on-premise or in different clouds. So there are operators for different clouds. So you might want to look into that. So they support at least all of the large hyperscalers, and I think they also support on-premise. It's backed by SAP, and they also use it internally. So it's definitely something that's not going away tomorrow. Yeah. So it has reached a certain level of, I would say, like confidence and trustworthiness, since it's already used in production. It's an open source project. So if you're considering like solving the multi-cluster problem, the multi-tenancy problem by having separate clusters per tenant, then this is probably one way to solve it in a scalable way.
All right, I think we have time for one or two more questions. Anybody else? I can see it. Yeah, I think I see a hand over there, just at the entrance.
Thank you for your talk. Not entirely tied with technology per se, but you mentioned security teams. And I do have the information and the output of tools that help with security topics, but I don't have means to mandate applying corrective measures. What is your opinion in that regard? Mm-hmm. Soft mandate or mandate?
Mm-hmm. So yeah, I would recommend using something like maybe OPA as a gatekeeper or something like that to really enforce your policies and achieve like security by really kind of defining it so that there is no way around this. Of course, there might always be certain exceptions for certain, but these you can kind of then allow explicitly. But I think, yeah, the advantage with like policy as infrastructure as code and things like that, we can also have like policy as code, and so we can define our policies once and like scale them to all the teams and projects. And I think this is definitely the way to go. Yeah, you can enforce that, or you can just have alerting. But of course, like we all know what the pros and cons of these two approaches are. And yeah, like OPA gatekeeper or something like that might be a useful tool for that.
Okay, one last question. Anybody? I can't see much. Yes, one hand. Yeah, over there.
Hi, Marc. Thank you for the talk. Really great. I would have one question. We already heard about eBPF today, and what's your opinion on that from a security point of view?
Okay. Yeah, like maybe I will answer it for like service mesh in general, no matter how it's implemented. Of course, you could solve some of the security issues on the network layer with a service mesh. You could solve it with a network policy, you could solve it with a service mesh. With a service mesh, you might also be able to solve other problems like certificates and things like that. Yeah, it's probably like similar with Kubernetes itself, so it adds another layer of complexity. But if it's the right fit for you, if you can tame this beast, if you have the know-how in your team to handle that, then why not? So it's also there, or at least like most of the service meshes are also there for security, and they allow you at least on the network layer to really take care of certain of the network security problems. But again, another level of complexity, another component you have to manage, another maybe attack vector if not maintained well. But generally, I would see it as a positive tool that from a certain level of complexity can help you reduce this overall complexity again. Yeah.
All right, then thanks again for the awesome talk. A warm hand of applause.
Thank you.